All right, so this is the first of our week 4, chapter 10 answer keys. We're doing page 646 today. Again, remember that I'm going to share these PowerPoints, so you could just go into Teams and kind of check over them really quickly, but this is a great resource for you to go in and kind of find a question that you have specifically and kind of listen to the explanation of it and see if that helps illuminate your understanding anymore. So I'm going to start on page 646, and for the 7 through 13, which were the areas of regular polygons, I'm just going to go through them one by one and go through real slow, so hopefully if you have any questions, you can get them answered here. So this number 7 was a decagon, so 10 sides with a side length of 4 yards. So I remember I told you in my lesson that my decagons are pretty awful usually, so this is supposed to be a regular decagon, so pretend it is with a side length of 4 yards. So imagine if I had drawn my radii in here and split it up amongst 10 like segments, then I'd have degrees that were 36 degrees in each of those central angles there, splitting it up amongst 10 parts. But then when I draw in that apothem, I have to split it up into 2 even parts, right? So 36 cut in half is going to be 18. So if I look at this triangle right here, I have an 18-degree angle up here, and I'm trying to find the apothem. So I'm going to use tangent, so opposite over adjacent. Tangent of 18 equals opposite over adjacent. I'm going to multiply both sides by a and then divide by tangent of 18. So I get that my calculator ready is a is equal to 2 divided by the tangent of 18. I get in my calculator approximately 6.16. And then my perimeter is going to be 40, right? Since my decagon has a side length of 4 yards, multiply that by 10. My total perimeter is 40. By the way, a lot of people miss this step and try to just use 4, in which case your answer is going to look different from mine. So the area should be 1/2 of 6.16 times 40, which gives you 123.2 yards squared. And remember I said in my PowerPoint lesson that I gave to you guys that sometimes I will, use 3 decimal places or use the whole thing. What I've noticed is that the book actually rounds to 2 decimal places when they get their apothem or when they get their side length. So their lengths are going to be approximated a little bit differently. So you might have something that's a little bit smaller or a little bit larger than 123.2 yards squared. And as long as you have the same kind of formula that you're plugging into, you're using 40 for the perimeter and pretty close to 6.16 for your apothem, as long as you're in the ballpark, it's good. You're good to go. Number 9 is a nonagon, so that's 9 sides with a radius of 7 inches. So again, just use your imagination, pretend this is a regular nonagon. Here are my radii of 7 inches with my apothem kind of drawn in there. So remember, I'm going to do 360, split it up into 9 parts, and that gets me 40 degrees in this whole angle formed by both radii. But when the apothem splits it in half, right, 40 divided by 2 is 20, so I have a 20-degree angle kind of formed by the apothem and the radius. So looking at this little triangle here, to find the apothem, I'm going to have to use cosine, right? Adjacent and hypotenuse. So the apothem is going to be 7 times cosine of 20, which I estimated to be 6.58. Then, because we only have the radius, remember we did one of these examples in my PowerPoint, was that with the radius, we have to go back and actually find the side length. So to find the side length, which will help us find the perimeter, I went back to that radius just because the radius this is an approximated number, right? I could hypothetically use that apothem, but since it's approximated, it's just going to kind of keep, leading me down a more approximated path. So I'm going to stick with my 7 inches that I know. So I'm going to use sine opposite over hypotenuse. I get that x is approximately equal to 2.39. Well, remember that the total side length has to be this number x multiplied by 2, right? If I go way back over here, 2.39 is really just that half of that side length, right? So to find the full thing, I have to multiply it by 2, and I get 4.78, which is what I have here. And then to find the perimeter, I have to multiply it by 9, so I get 43.02. So using these approximated numbers to find the area, this is what I got was 6.58 and 43.02. So I got 137.2 inches squared. So that's using rounded numbers. What I noticed in the book, even though I literally said this on just the last problem, was that they actually use the unrounded numbers. So the book is not being very consistent with their answers here. And you'll see there's quite a difference between using the rounded numbers and using the unrounded numbers. So again, as long as you're in the ballpark, you're good to go. On number 11, this is one that I tend to get a lot of questions about because the numbers are really, really small. This is talking about a 20-gon with a radius of 2 millimeters. So here's my 20-gon, obviously. My central angle, if I take 360 and divide it by 20, is 18 degrees, right? So if I draw in my radii, so when I draw in my apothem, which I kind of have like a zoomed in version here, right? Here's my apothem down the middle. That divides the 18 degrees in half. So I have a triangle with this kind of top degree of 9. So in order to find the apothem, I'm going to have to do the cosine of 9 because I want to use adjacent and hypotenuse. I get that my apothem is 1.975, so I'm being so inconsistent here. I use 3 decimal places here. For the side, again, I'm going to use sine, so I'm going to use opposite over hypotenuse to find the side length, which is 0.313, or you could even round that to 0.31, but that's just going to change your final answer a little bit. That means that the entire side, right, since this length that I have here is just half of that side length because it's the base of the triangle, the entire side, if I multiply it by 2, would be 0.626. And then if one side length of the pentagon is 0.66 and I multiply that by 20, I'm going to get 12.52 millimeters for my perimeter. And keep in mind that if you're estimating or you're approximating or you're rounding off sooner than me, you're going to have a slightly different answer here yet again. So using my 1/2 apothem and perimeter, I get 12.4 millimeters squared. And I believe this is the book answer. So remember that I'm trying to compare my answers closely to the book or as closely as I can, but as long as you're in the ballpark, somewhere around 11, 12, 13. I know it's kind of weird to not be getting exactly the same answers on all of these, but because the book's being a little bit inconsistent and I'm being a little bit inconsistent, there's no way that we're really going to keep all of our answers exactly the same. Okay, so finally, number 13, we're doing a 15-gon with a perimeter of 180 centimeters. So just to kind of start out, we already have our perimeter, so that's great, right? We want 1/2 apothem times perimeter. But in order to find the apothem, once I start sketching everything in, I am going to need to know the length of one side so that I have kind of the base of this triangle since I don't have a radius here. So I don't have this written down. But since we have 180 centimeters, I'm just going to take 180 and divide it by 15. That gets me 12 for each of my side lengths. And then to find kind of just the base part of this triangle, that shorter leg, I'm just going to cut 12 in half, right? Because we know that that apothem is just going to come down and slice that side in half. So then to find the angles, right, I'm going to do 360 all the way around is 360 divided by 15, and I get 24 degrees, and then the apothem splits the 24 in half, and so I get a degree of 12 at the top of this triangle. So now I can find my apothem. I kind of have it redrawn over here. I have 12 degrees up here, a leg of 6, and I'm trying to find my apothem over here. I'm going to use tangent of 12 equals 6 over a. I promise that's a variable. So I approximated that my apothem was 28.2277, and again, being so inconsistent here. But I'm trying to leave as many decimals as possible so that hopefully I get sort of consistent to what the book has. So my area is 1/2 180 times 28.2277. So this was the official book answer here, was 2,540.5 inches squared. But again, if you have this rounded to maybe like 28.23, you're gonna have a slightly different answer than I have here. So just make sure you're kind of in that ballpark. All right, so on numbers 15 through 19, the odds that we did, on number 15, you should have drawn in your height here, and I'm going to use this 5.5 as just, I'm going to represent that with 5.5. So if I want to find the height, right, I'm going to look at this triangle here. I'm going to use the sine of 33 equals opposite h over hypotenuse 5.5. Multiply both sides by 5.5, and I get that my height is 3.02274. And then I have to go through and plug that in, right? The base is 12, the height is 3.02274, and then 1/2, right? Because it's a triangle, so I get 18.1 squared. Be careful not to forget that 1/2. I noticed on our quiz that a lot of people were forgetting that half there. On number 17, to find the height, again, I'm going to just draw in my height here with the 90-degree angle. I'm going to use sine of 28 equals opposite over hypotenuse, which I have up here. Multiply both sides by 34, and I got 15.96 approximately for h. So again, I'm just being not consistent really here with my rounding. But I got area equals 1/2 base times height, where my height is 15.96, and then the base is going back to the big triangle, 39 kilometers. So I get approximately 311.2 kilometers squared. So again, depending on how you round this, it's going to look a little bit different at the end. Number 19, I drew in my height here. I'm going to use the sine of 37 equals h over 1. That's kind of convenient because h divided by 1 is just h, so I don't really have to do any extra math. That's 0.60 approximately in my calculator. So again, the base is 2.5 or 2.5. So it's going to be 1/2 base 2.5 times height 0.6. And that gets you 0.8 feet squared. All right, on number 20, we have PQRST, which is a regular pentagon with center O and a radius of 10 inches. So I sketched in my radius over here, 10 inches. And then we need to find each measure, and if we need to, round our answers to the nearest tenth. So the measure of angle POQ, that's this whole big central angle here, is going to be 360 split into 5, 72 degrees. For the measure of POX, that's just split in half by the apothem, right? So 72 divided by 2 is 36. To find the length of OX, that's the apothem. So I have this kind of sketched out over here, a triangle with the apothem and the radius 10 inches labeled and the degrees of 36 degrees up here, and use trigonometry to find A, and I got 8.1 inches when I rounded it up. To find X, again, I'm going to sort of ignore that I know the apothem, it's 8.1, but that's an approximated number, and 10 is an exact number that's given to me. So I'm going to use sine, opposite, and hypotenuse, since 10 is more exact. Multiply both sides by 10, and I got X was 5.87 for just this piece of the triangle. But you notice that we're actually asking for PQ, right? So we actually have to double that number and get 11.8 approximately. For the perimeter of PQRST, since my side was approximately 11.8, I multiplied it by 5, and it looks like that gave me exactly 59 inches, but the book said 58.8, so it probably depends on how the book is rounding. On F, we're looking at the area of PQRST, so we know it's 1/2 apothem, which is 8.1, times my perimeter, which was 59, and I got 239.0 inches, but again, the book said 237.8, so if they're not estimating or they're not using these numbers rounded to the nearest tenth, they're going to get a slightly different number than we are. So as long as you're kind of in the ballpark of 239 or 237, somewhere in there, and your numbers are looking pretty close to mine, then you should be good. Number 23, we're finding perimeter and area of each regular polygon to the nearest tenth, and this is a regular triangle or an equilateral triangle. So if I kind of draw in all these numbers that I know here, it tells me that I know the radius is 4 meters. So if, remember this is an equilateral triangle, this is 60 degrees. So if that's split in half, it's 30 degrees. Or I know that this whole thing is 120 and that split in half is 60. So however you split it, we've got a 30, 60, 90 triangle. So if the hypotenuse is 4 meters, the short leg over here will be 2 meters, and then the long leg will be 2 squared of 3. So my apothem's 2 right off the bat. If this part of the triangle is 2 squared of 3 and I double it, I get to 4 squared of 3 for one side length, multiply it by 3, and my perimeter is 12 squared of 3. Plug it into your formula and you should get 12 squared of 3 meters squared, but it did ask us to round it to the nearest tenth, so I just plugged that into my calculator and got approximately 20.8 meters squared. Last one, woohoo! This is a 10.4 review problem. We have two regular octagons shown. It asks for the scale factor, so we just take 6 and 9 and put them over each other. We get 2/3, and that's our like A over B number. And then part B asks for the area of the smaller octagon. So since we have similar octagons here, right, they're regular, so we know that they're similar. Rather than having to do all the trigonometry stuff and figure everything out, we can just use the area ratio. So I know that my area ratio, A squared over B squared, will be 4 over 9. And I can just say, okay, 4 over 9, right, smaller to bigger, is going to be smaller to bigger of the areas that I know or don't know. So this one's going to be an unknown, and this one's 391.1 inches squared. I can just plug those into the ratios that I know and cross multiply and solve, and I get 173.8 inches squared. So you could go through, now that we know all of our trigonometry stuff, you could go through and make the apothem and split everything up and do all the trigonometry and figure it out. And you should get to the same thing, but it's a lot quicker to just make ratios for this one.